Like I started, we are very excited to have Chao Huang here. Chao is an assistant professor and PhD advisor at the Department of Science and the Institute of Data Science at Hong Kong University, and he's a director of a data intelligence lab at HKU. And he has been doing a lot of interesting work in the space of agents for scientists, for science. And today he's going to tell us about from LLMs to agents, challenges and opportunities. Chao, please.
Okay. So probably I will share my screen.
Yeah, it'd be great. Thank you.
Okay. So does it look good?
Yeah.
First. Okay. Yeah. So great. Okay. Thanks for the introduction of Chen Hao. Okay. Thanks for giving this opportunity to share some of our research work. So I'm Chao. Yeah, I'm from HKU, University of Hong Kong, and I'm an assistant professor. So I think in recent years, so we are working on LM agents, and also with some foundation techniques can be used to support agents. Okay, so here will be our recent works, and so we release some open source projects, and including some RAG, light RAG anything, and also some coding agents, deep code, and also working on some AI scientist, like AI researcher. Okay, so here will be our GitHub platforms, and so we release most of our research works on these GitHub platforms, and so feel free to stop by our site and to explore all the techniques and which are relevant to our released open source techniques. So because the reasons and motivations for doing some open source research, because we would like to encourage the community to further, just to do the further development and based on our experimental findings, and can also, just to working together to advance this research line. Okay. So in this talk, I would like to, just to explore the potential of the AI agents to probably will become the next artist, financier, engineer, and also scientist. Yeah, because now with emergence of LLM, so we believe probably it's especially for AI agents, we figure out that probably is the potential, and we can amplify the just the capacity of the AI agents and across different domains. Okay, so at the beginning, so we probably like to briefly to introduce. So recently, I think we have so many, just to we have so many researchers working on the AI and also large language models. So I think probably we have two lines and working on the AI LLMs. So first lines we can just consider it as LM intelligence. So it's we try to just the community try to train and to including pre-training and post-training, and to build some very powerful and large language models. So we can create LM intelligence like DeepSeek, like crowd, like deep, like Qianwen, and so these lines to working on some to enhance the capacities of the LLM. And so another lines I would like to say will be focused on the how to just effective and efficiently to manage the context, which are also very important. We can call it like a context intelligence, like including some RAG and also some just as agents, and also some tool use, and how to build some effective memory, and how to just to build some a data interaction components with the RAG. And I think so for this part we can name it as like a context intelligence. So so in these components, probably, so I think I would like to mention that the memory. Okay, so also very important because we can consider memory as like a short-term and also long-term memories. Yeah, because different context and also task may involve different techniques and to how to do a very effective and efficient context management. Okay, so to provide some foundation techniques for agents, I would like to, just to introduce four of some RAG techniques, and which can be used to tackle different challenges, and also can be used to across different scenarios. And so first, I would like to say probably I think that for currently the knowledge, especially if we have a massive data, right? So how to effectively to organize and manage the data. So we can consider, so the knowledge itself is not like independent. So we have to, just to consider the interdependencies across different like entities and also the knowledge. So here, the current like problem is like a previous some naive rack. Okay, so the techniques working on some, just consider that different knowledges and to be independent. But in real world, the knowledge are not independent. Okay, so we would like to, propose some, just very useful structures and try to correlate and relation, different like entities and knowledge. So here I would like to introduce like graph structure, because graph is very useful structures can be used to capture the interdependencies across different like knowledge entities, like locations, events, and also some, just times. And so so that will be, just the graph brings a good insights and how to, organize the knowledge in our, just real world applications. So benefit and inspired by this, like, the usefulness of the graph data, and we build some, RAG techniques which are relevant and to, just to the RAG. Okay, so here's I would like to introduce the light RAG, right? And for inspired by the graph RAG techniques, and so our light RAG tackles, just towards the effective and also the simple and fast retrieval augmented generation techniques. Okay, so in our light RAG frameworks, we first, just to consider to bring the benefits of the graph structure into how to organize the data and try to do a very good, just the index and also the retrieval parts. Because for the RAG techniques, I believe the two key techniques and components which are relevant to RAG will be, the first will be the indexing, and the second part will be the retrieval part. Okay, so for the index part, we leverage the graph and the structure and try to, just to extract the entities from the massive like text data. And also we also try to build the strong relationships between different like entities and relevant to the different like knowledge. And so that will be the methods we try to use and to build the index. And for the retrieval part, and in order to achieve efficiency for the retrieval, okay, so we try to, just to leverage and like to integrate the vector database and also the graph database. And we try to integrate the two types of the retrieval techniques and to build a joint like retrieval schemes and mechanisms, and try to joint to capture the like both the entities and also their relationships as well. Okay, so that will be our dual level retrieval, and try to, just try to organize the data and to do effective like indexing and also retrieving. Okay, so and for another, the try to reflect the dynamics of data, because now I think nowadays the data is dynamic and is arriving over time. So we have to, just to build some RAG system which can be used to handle some dynamic data and in just time-aware environment. Okay, so to address these challenges, so our like adaptively components is proposed to just such like dynamic data changes, and in these ways we can build our systems and RAG systems to be used to deal with the dynamic data and which can reflect the time awareness. Okay, so that will be our frameworks of the light RAG. Okay, so so here is will be our light RAG, because some has been summarized in different like YouTube, and so we have provided some, just tutorials for the short summary of our light RAG frameworks. Okay, so and to address like after the light RAG, so we figure out one challenge which has not been fully addressed, because light RAG is focused on the text data. I think that will be also be the focus of the many existing RAG techniques. But in our practical scenarios, just we have, the documents and we have the data to be multimodal in nature, right? So because probably we sometimes we have the not only the text data, and we also have some doc files, and which contain some tables, formulas, and also the images, right? So that will be the very, common like scenarios we have to deal with, and in our practical RAG scenarios. So that will be the motivations, motivate us to propose one unified RAG frameworks which can handle, just different modalities of data. Okay, so that will be, the motivations why we to extend, just propose a unified RAG frameworks where RAG anything and it can be used to handle the multimodal content across different modalities. Okay, so in our RAG anything frameworks, for different modalities of data, and we build some modality aware index. And also for the retrieval part, we also try to build some modality aware retrieval schemes which can be just to integrate together. And we try in these ways we can extract and retrieve some relevant content from the massive multimodal data, which can in response to the user's query information. Okay, so that will be the pipeline of our just RAG anything frameworks. And so in this ways, we try to just the knowledge graph is not like a text based, so it's a multimodal knowledge graph. Okay, so in this ways, we can not only capture text data, and we can also our retrieval and indexing components can also just to be reflective of the multimodal and different like a data. Okay, so that will be the frameworks of our RAG anything. Okay, so and after the light RAG and also the RAG anything, we think about what might be the next for just to can be the key components which can be used to as a foundation techniques for support agents. So we're thinking about the first names which we would like to explore will be the on-device scenarios, will be the properties, will be the age size, because currently most of the LLMs as well as agents are proposed and developed in some just our cloud-based models. But actually, we have spent much times of our daily lives with our smartphones. So it will be very necessary and important if we can bring the benefits of the large language models into our smartphones with the on-device environments. Okay, so that will benefit our just many applications and our daily use. But one key challenges my problems will be raised will be because we are the data we have in our smartphones are super sensitive, and most of the data will be our private data. So it becomes very just a difficult and challenge we just to take the data out of our smartphones and upload it to the cloud. So with this, with awareness of such challenges, we have to just to build some like a local models which can be deployed on device. Okay, so that will also bring the challenges, because I think that the powerfulness of the large language models due to its like large scale parameter size. But in just to enable our on-device AI, we have to we have to bring the just to send the model to the on-device environment. Okay, so that will be the challenge. But we believe that for our just smartphone and mobile phone usage and the environment, it is necessary to build some just some agents and RAG techniques which can enable users to interact and chat with your data on your phone. Okay, so that will be the first lines we try to explore. And another things, I think the data, especially for the video data, is also our just a very ubiquitous. So, but currently, the current techniques cannot support us to just to chat with our videos, especially for the extremely long context videos. So the limitations for the current multimodal language LLMs might be just the input limit length of the input videos. It probably cannot support extremely long context videos. But in our practical scenarios, we have so many applications and scenarios. We have to deal with extremely long context videos. Like properties will be the length of the properties will be several hundreds of hours. So okay, yeah. So that will just bring the new challenges for the multimodal large language models. So we are thinking about the possibilities if we can build some just the RAG techniques or some agent techniques which we can enable users to directly chat with your videos and chat with your extremely long videos. So by addressing these challenges, there is no need to just to go through all the details for the just for the extremely long videos and for tutorials and like probably some lecture recordings. We can directly chat with your videos, and we can probably we can get grab some key takeaways and insights from the videos data itself. So that will be very useful. And also for another thing, so if we have some probably some just some personal recordings or personal videos we recorded during our trip, right? So it might be very super awesome if we can directly chat with your videos and to capture some visual features or visual context from the extremely long videos from your just from your like mobile devices. That will be probably, I think the second nice will be just to use some AI techniques and to enable the user can chat with your extremely long videos. Okay, so that will be just the two key lines we working on, and after the light rack and also the rack anything. Okay, so to address the above challenges, so we first propose a mini rack. Okay, so the mini rack is proposed to tackle the on-device like a data agent, because we propose a mini rack techniques which can be used to chat with your data on your phone. Okay, so the key techniques in our mini rack is we propose some just the lightweight graph-based knowledge retrieval scheme, and which can work with some small language models, because it's like an on-device environment. So we have to just to build to design some algorithms which can work well with some small language models. Okay, so here's we define the on-device like models probably with a parameter size less than 3 billion parameter size. So in our mini-rag frameworks, we work with such like small properties will be the small parameter size model. Okay, so that will be the motivation of our mini-rag and also the frameworks of the mini-rag. And also for the video rag. So the video rag is proposed to just to address the challenges of the just enable users to chat with your videos. But the video is extremely long. Okay, so here's the video properties. We have like more than 100 hours of length for the videos. Okay, so in our video rack, so I have two channels for the index and the retrieval. Will be considered. So first we consider the text-based textual modalities of the data, because for the videos we have the subtitle, we have some caption data which can extracted generated from the video itself. And another dimension will be some visual features, and also some audio features will be the background music. Okay, so for these two channels, we do separate like index. Okay, so the first ones we we can follow some text-based indexing and also the retrieval. And for the another type of modality, and we just to use some just like some visual tokenizer, and also we do some cross modality alignment, and to enable the query with the text and also the content with the different modalities can be aligned well in response to the queries. Okay, so that would be the pipelines of our video rack. Okay, so here to further just to enable our techniques can be used by the public, we also propose and develop some real systems. We call it like a Vimo, which can and everyone can download it from the GitHub and can play with it. Okay, so here will be the demo for our Vimo chat with your videos. Okay, please check it out.
Videos on the internet are packed with incredible amounts of rich knowledge. For example, when you search for LLMs on YouTube, you'll discover tons of educational videos bursting with valuable
insights. We
insights.
have so many.
Have you ever thought about having an intelligent agent that could help you understand all the content in these videos, allowing you to learn interactively directly through it? Today, we are proud to announce state-of-the-art AI-powered video understanding platform with intelligent conversational capabilities and comprehensive video analysis. Ready to jump into Vimo? Let's get the show on the road. To wake up Vimo, simply give that button a click to fire up the backend service. This kickstarts the loading of all the powerful AI models in the background. Once they're locked and loaded, Vimo is ready for action. Next up, let's get your content in. Hit upload your videos. For this walkthrough, we're using a great example.
So here we are.
OpenAI's official introduction
The video
to
data.
ChatGPT.
So this video is
With our video locked and
OpenAI
loaded.
released their ChatGPT agent video.
Click analyze, and just like that,
Now the video is trying to index the video.
start digging into the video's content. Once Vimo finishes its magic, you'll get a notification that everything is ready. The analysis process
Now
is a
the
deep
video
dive
can be indexed.
building a complete knowledge graph from the content. Now, let's put
And
it.
we are free to
The video is about ChatGPT agent from OpenAI.
Okay,
We'll start
so
with a
here's the
simple question.
What is ChatGPT
Tell us,
agent?
what is a ChatGPT agent? During this process, Vimo will delve into its complete understanding of the video, pinpointing key information relevant to your query to formulate a comprehensive
Okay,
answer.
so here will be the
As you can
answers
see,
and
Vimo
generated
returns
from
a detailed
the video
report filled with
data,
all
and it
kinds of
can
information
in
about
response to
ChatGPT
our
agents,
question, what is
with
ChatGPT
information
agent?
from the video's content. But why stop at a detailed report when you can grasp the essence of the entire video in a single glance? Let's challenge Vimo to distill its understanding into a concise summary. Let's just type in a request. Give me a summary about the video.
Content, and which can be extracted from the entire video.
After a moment of processing, Vimo delivers a perfectly articulated summary, proving it didn't just skim the content, it truly understood it. Vimo isn't just capable
We also
of
support
analyzing
like
a
a
single
multi
video.
videos,
You can
we
tackle
can
multiple
directly
videos
that
without any
videos and can
exciting demonstration. We vetted OpenAI's comprehensive Sora tutorial, which spans 6 different videos. Then we challenged Vimo with a simple yet powerful question. What can I use Sora for? Please provide a complete summary. The results? Absolutely impressive. By diving deep into the video content, Vimo accurately identified and summarized Sora's key capabilities with remarkable precision. It didn't just watch the videos, it truly comprehended them, extracting the essential features that make Sora such a groundbreaking tool. We've prepared a super user-friendly installation videos on.
Okay, thanks for watching the demo of our Vimo. So it's also fully open sourced on our GitHub. Yeah, feel free to try it. Okay, so after we build the video rack system, also the Vimo system, so we will also think about the problems for the like multi-modal intelligence. So probably it's like 3 key functions and features we are trying to just to purchase. So first will be the video understanding. So another one would be the video editing. So I think third category properties will relevant to the video generation. So we are thinking about problems. Is that very just so if we can bring the benefits of the agents into the video generation, can we address some key challenges for the current video generation techniques? Right. So we're thinking about the what might be the key challenges for the current like video generation techniques. Okay, so the first one will be the length. Okay, so current like models try to generate the videos, but with limited length. Probably will be the 8 seconds or 10 seconds. But our practical just a requirement for the video generation would like to just to generate some long just a long context videos. Okay, so that will be the one challenges for the current like video generation techniques. So another challenges for the video generation might be the consistency, because if we would like to generate some long videos, how to just ensure the self consistency for the content for the videos, that might be just brings new challenges. Okay, so in by just considering these 2 challenges, we are trying to think about, is that possible? So if we can bring the benefits of the agents into the video generation to address that challenges. Okay, so that will be the motivations just for the proposed VMAX, or like a agentic video generation frameworks, and try to just tackle the line of the video generation. Okay, so you can so here will be our demos. We just our VMAX, we try to generate it. Okay, so because for the video generation, so it's like probably it's very challenges to generate some long context video, because so first how to just to to ensure the self-consistency about different themes, different like content, and across different like scenarios. Another thing is how to align different modalities. For example, we have some visual modality. We also have some audio modality and different text modality. How to align different across different modalities that also brings new challenges. Okay, so here's you can check it out our generated content. Okay, so actually it's sometimes we can somehow it's hard to differentiate these some video generated content and which the real texting.
The slang to let's get this show on the road. She got you shoving the dough to try.
So this video is totally generated by VMAX. So there is no human inputs for this kind of like a video. So another one, because last week we go to just we went to attend the EMLP conference. So we generated just a video and we try to reflect just with a prompt with a cat is going to attend EMLP in Suzhou, China. Okay. We try to share, just sometimes we try to share authority.
For this moment all morning. Listen to that one going.
Keep taking it all in.
Okay, so yeah, and another, so we try to just generate some probably it's like some a little bit longer, just videos, and then with some just different like things and like very similar as a short series. Okay, so actually, so our VMAX is also fully open sourced GitHub, and feel free to check the video demos and generated by VMAX. So this will be the video we generated relevant to things of the F1. Okay, so thanks for watching. Okay, so so in the previous sections, we're talking about just to how to use AI agents and to deal with some multimodal data. And so we also our lab also proposed some just some other just agents relevant to deep research and also coding and also AI scientist. Okay, so we first propose just auto agents, which is can be considered as a deep research and which can help you to retrieval information and then do the summarization and also to analyze the data and then to finally to generate the comprehensive reports. Okay, so I think here's I would like to emphasize one point. So that now the agents should properties will be one important feature for the agents will be self-involving because the agents can just always just have to encounter some tasks the agent cannot to finish by with its like current capacities. Okay, so that point means the agent should be self-involving and with self-learning techniques, and so try to properties, for example, like try to build or create some MCP tools, and also just can help to grab some like knowledge from the web and to summarize the key information and to help to do the planning part for the self-involving. Okay, so and then another thing is we also just some for the agents, because I think currently so the exploration for the on-device or mobile agent is still under exploration, and I think the key challenge for the mobile agents will be just how to with the cooperation between the cloud model and also with the on-device environment parts. Okay, and so here will be our demos, because we also train post to we also build some like lightweight like mobile foundation models which can be used to help for our form use agents. So now our agents can be used to manipulate or control, like just to like 25 like different apps or use this mobile phone parts for that. So our lightweight light agent model, it will be like with a size of the like 3 billion size for which can fit the current like mobile environment for that. Okay, so yeah, because we explore the the potential of the AI for the for artists, and also sometimes can be used for as a general agents. So and we recently we launched a project we call it like AI Trader. We try to just to explore the potential of the AI as like a financial for the just for the trading. Okay, so here's we just try to bring the different like large language models, work with some just the agentic like frameworks and try to do some trading on like to do some compete and like arena and for the trading. Okay, so so here will be our just the result for a compete different like models and to present. And so actually our this project is a live show, and so it can is like a real-time financial environment, so everyone can watch the live show and in a real time just environment, and to check like to check the analyze and also the reasoning like just process of different like large language models and compete for the trading. And the benefits and the returns for the large language models is also reflected in the system in real-time manner. Okay, so here we also just to try to just to output and the reasoning process and reasoning insights for the different large language models towards to the different like training and transactions for different models. Okay, so nowadays we support different like a US market and also the mainland China market. Okay, so that will be probably will be a very interesting just to experimental study to try to explore the potential of the AI agents for as a trader. Okay, so and then we are, I think another two key just the roles for the AI agents might be the engineer. Okay, so to address the like AI engineer, just we propose like a deep code. So we try to towards like open agentic coding, because currently like large language models can generate the code, but our just our practical coding scenarios may involve not only like probably like very complicated like workflows. So we try to first generate data, generate the code, and also prepare the data. And we also to validate the algorithm and the algorithm implementation. We try to tune the model and optimize the model, and we configure the environment, and we do the back and forth and try to optimize and tune the algorithm again. So it's a very complicated like a process. So we try to just to our deep code is proposed to tackle this line of try to do some properties. I think one important feature for the deep code will be the paper to code. So because we have so many papers, but not like open source, they're just the code. So it will be very helpful if we can input the data into the agents and output the property accurate and efficient like a code implementation for the algorithm proposed in this paper. Okay, so that would be the key, the function of the deep code. Okay, and so and finally, so we launched a project we call it like AI scientist, okay, and AI researcher. So we try to just to explore the points of the like can AI be the core scientist of our researchers, because we are doing research. Okay, so we are thinking about the problems. We try to summarize our research process into different stage. So first we have like the first stage might be the literature review. Okay, so in this stage, we probably will survey and review like massive like papers from the web, and the probably will try to filter out some noisy information and generate some just insights, extract the insights from the massive literature review. And then we try to come up with some the novel ideas, and to generate some cool ideas, and to be novel and also the feasible. Okay, so that may take a lot of time, because sometimes it's hard to survey and review massive information and from the web. Okay, so after that we have an idea ready. Okay, so then the next step is try to design and propose some new algorithms, and the algorithm implementation and validation may take much times, right? Because sometimes we have to do a lot of like a failure test, and also to try to optimize the algorithm and the back and forth, and try to tune the algorithm and to validate its effectiveness. So that's also just very time consuming, and so we have to just to do to probably we have a lot of like tests across different like algorithms parts. Okay, so for these like probably the stages, we think about the problem. It might be very useful if we can bring some repetitive like a task and to the AI, and then the researchers can just spend more time focusing on the innovation, instead of just to do some repetitive like times and repetitive like a task for that. Okay, so that would be the motivations. We try to build some like AI core scientist to be the co-pilot for the researchers and the scientist parts. Okay, so let's release the Lobix. Okay, so the Lobix will be try to do the agentic like a core scientist. Okay, so I think the AI core scientist probably we summarize like 4 key functions and features relevant to the AI core scientist. So first will be the deep survey. Okay, so deep survey is relevant to deep research, but here's the resources my properties will more focus on the technical side. Okay, so I think that in the web we have a massive like information. So, but how to summarize the key insights from the massive information, that brings the challenges. So in these ways, for doing a good like deep survey, we have to just to assign different weights to different like data source information resources, because we have to determine we have to decide the reliability and trustworthiness of the different like information resources. Okay, so but how to index them and how to summarize them might be just to bring the challenges for deep survey. And another thing is the idea spark. Okay, so for the idea spark, I think that for doing research, come up with some idea. It seems like we try to summarize, we try to do some reasoning, multi-step reasoning from the insights and knowledge we extracted and summarized from the existing research works. Okay, so in this ways, the AI agents have to demonstrate the capacities for the multi-step reasoning, and then can result in some novel ideas which can be just too interesting and also feasible, because after the multi-step reasoning, the problem is that the AI agent should know what might be the next breakthrough for the different research lines. Okay, so and for the doing research, sometimes for the auto experiment may help just the researchers to do some coding and experimental task and try to do a lot of like a test. You imagine, so if we can only test one algorithms within 1 week, but now with the AI agents, we try to test like probably it's like 10 or 20 like different types of algorithms within 1 week. That may maybe brings just maybe more efficient compared with some traditional just the working style. Okay, so finally, Jupyter Notebook will be the data analysis. Probably sometimes for different like domains of like chemistry and also some bioinformatics, finance. We have many data. Okay, so but how to do the effective like data analyze, and so that will just we can just to ask AI agents to be our co-pilot to analyze the data to become our data scientist. Okay, so here will be some just the demos. Okay, so I think that to build some just the AI scientist, the first components for just try to generate a deep survey reports, and I think the key part here will be how to filter out some noise from the massive information. So to address these challenges, we just for different we first to decide like which papers and also which like GitHub repos will be the more reliable and trustworthy, and then we do different like weight assignment and then to summarize the key information. Okay, so here will be the demo for the just for the how to do the idea spark, and we generate like a different and to do some reasoning across different like research directions and to with some new ideas proposed. Okay, so so here's the AI agents can also just serve as a roles for doing some experiments, and also just to do some like to how to pick up the data sets for the evaluation, and how to pick up the baselines for comparison, and which benchmark will be suitable for your algorithms. And so that will be the also be the whole the key themes for the evaluation and the experimental things for that. Okay, so that will be so in order to just try to just to evaluate the limit of the AI agents for as a co-scientist, we ask our AI agents, and also just to generate some research work from end to end. So it means there is no human involvement in this like research pipeline. So the only input for this like research for the AI co-scientist will be only the like several paper references. Okay, so we just input several paper references for the AI, and we ask the AI to conduct some novel research based on the references. Okay, so then the AI first based on the provided references, the AI goes to do the literature review, come up with some cool ideas, and then the AIs try to just to implement the algorithms, and to validate the effectiveness of the algorithm, and do all the experimental settings, and to finish the experiments, and then eventually finally the AI generates the papers. Okay, so here will be the papers we so generated totally generated by the AI researcher. So all the papers has also been open sourced to our GitHub. Okay, so feel free to check the papers totally generated by AI. Okay, we try to see just so how the quality of the AI generated papers compared to the human generated papers. Okay, so so here you can say that we use the iClear template for the paper, and so the AI, you can observe that AI can also do the derivations and also to do some experimental things for the different to propose the algorithm, to validate the algorithm, and also to pick up the data sets for the comparison, and also just the finish the paper by the AI itself. Okay. Okay, so that will be our the results, the experiment results we generated by the AI. Okay. Okay, so and also here will be the codes totally generated by AI. There is no one line generated by human. Okay, so that will be the papers. Okay, so this will be our technical report for our AI researcher, which has been accepted by NeurIPS this year. Okay, so and also all the tech leaks has been open sourced on GitHub. Okay, so feel free to explore it. Okay, so so all the research work I would like to just give the credits to our team. So I feel very fortunate to work with such a like a passionate team. So okay, thanks to the team. Okay, so yeah, so that will be the content I would like to share today. And thank you again for listening and attendance. Okay, thank you.
Oh, yeah. So thanks for the great talk. I'm myself a user of the AI researcher. I like how you guys engineered everything down to the details. So I guess I have a like high-level question regarding the design. Like so when I was using AI researcher and other systems for automating experiments, I often find that it's easy to run into this zone of making everything very specific, but the result will also get kind of constrained in the target space, and we lose some of the diversity there. So have you guys run into that issue, or do you have any suggestion how we can improve that?
Okay, so here the diversity, you mean the different domains?
It's one is that, and also it's like if our instructions for the say the experiments and the research pipeline is very specific, then I personally observe that the agents will run into like similar research pipelines for everyone, and then to me that sounds like we are losing some of the exploratory or diversity part in research. Yeah.
Yeah, I see. I think that's a very good question because I think the AI researcher should have such kind of like a diversity because to fit some personal context. So I think to address this kind of like challenges, I think another thing is to try to bring the the personal context into this like a pipeline and also the frameworks. Yeah. So for example, if different persons also just to propose some very similar prompt. So at the beginning, probably the AI agents will do the similar like information retrieval and from the same like information resources. But based on the feedback, I think if the different persons provide some different feedback, the agents should be realized that okay, so they should provide some different like a context in response to just to the diverse like a context or some other different like personal information part. Okay, but it's very, I think also it will be the challenges for for the large language models if the just the two persons propose some similar prompt into the same LM. So how the LM can the response from the generated by LM can be reflective of the different like diverse context to different persons.
Thank you. Yeah, as a follow-up question, I think yes, I think if you I agree that if you provide some more like personal context at the beginning, then we may be able to introduce more diverse behavior. But I guess it's still a little unclear that, for example, if I were interacting with an AI researcher or AI assistant, it would be nice to have those like intervention points in the middle so that I can input my, say, my personal taste or my standards for research outputs.
Yeah.
I guess, yeah, that sounds like a more ideal pipeline to me. But anyway, I guess on the high level, I'm still a little. It still seems a little unclear that how do you make sure the AI can do like diverse style of research such that we can say, for example, in the future, maybe someday we will use those AI researchers to do like a bulk of research. How do we prevent that? How do we prevent something like mode collapse in that collection of research papers? And we are, I don't know, we are certainly we might be limited in just some targeted distributions, and we are, we are not seeing like different branches anymore.
I see, I see. Yeah, that's a very good question, actually. So I think for the AI researchers, so the proposal of like an AI scientist or AI researcher, I think is not to replace humans. Yeah, because we believe the importance of the human and also the human expert and also human knowledge will be very, just helpful and valuable to the scientific discovery. So here, I think the one key, just the roles for the AI scientist is here in our research is to help us to do some repetitive, the task in our research, like pipelines. Okay, so but for as you proposed, I think for the AI researcher, for each key stages, so the human will take the responsibility for the result double check. For example, after literature review, and so the agent should provide the survey information for the human to review. So if the human say yes, okay, so the agent should go to the next stage for some properties, come up with some cool ideas. But the agent should propose the ideas, different ideas, but the human should to decide which one will be properties will be the target ones. So I think for each key stages, the human is also very important to make decisions and also to double check the results. So I think that here's the AI agency help us to do some, just a very time consuming and also boring. It's not super novel task in our research pipelines. Yeah.
That makes sense. Thank you.
Thank you.
Oh, yeah, thank you. And may I ask one question? I think the AI research is very attractive and amazing. May I ask, have you ever used the AI researcher in physics or chemistry area research?
Yeah, so yeah, that's a very good point because I think that because for the different like more diverse like domains, the researchers from chemistry and also the physics might not just may knowledgeable, especially for coding compared with the AI researchers. Okay, so I think that currently for the most of the just the adopters for AI researcher from the chemistry and the physics may use the functions of deep survey. Okay, so they would like to just to use the AI researcher or Lovix to help them to do the literature review and to survey some relevant literatures from the massive data. But for the another thing is for the physics and also the chemistry, because they also have some just the data collected properties will be records their just the experimental findings, and also they can use the AI researchers and to help them to analyze the data. Promise will be try to identify some key patterns from the data. Okay, so and also to generate some visualization results from the data. Okay, I think for that will be the two key, just the two key perspectives we observe from the users from the physics and also the chemistry domains.
Yeah, I see. Thank you.
Thank you.
Thank you, Professor Huang. Thank you for the great talk. And I also have a question. I feel that nowadays one issue with agents, especially in academia, is that while these agents are designed to do some tasks and they have the potential to do it, its real effect, its real performance is not guaranteed. and this makes it difficult to use these agents in real world. So I wonder, like, do you share this impression, and have your group explored some ways to like make the agents truly usable?
Yeah. So yeah, I think that's a very good question, because currently I think one key challenge for the building the strong agents will be how to evaluate the agents, right? So for example, for different domains, for AI scientists or AI researchers, how to evaluate the results for the AI researchers, that will just will be the a big challenge for domains. So here's, I think, we might have some benchmark which can be used to test or evaluate the performance of the different like AI agents. But some kind of like especially for scientific discovery, it's hard to quantitatively just to evaluate the performance with some scores. So I think so in this way, sometimes I think will be the big challenge for the entire community. But I think now we are also, I think different also, just institute or some researchers are working on some, try to propose some new benchmark which can be used to evaluate the like some new agent assistance, right? So that will be very useful if more benchmark can be proposed to just to do this kind of like evaluation. So if we have we evaluated just a different like AI agents across different benchmarks, I think that will be a big step just to put our AI agents into some practical use parts. Yeah. So but I think currently may probably is the two most used and AI agents will be, the first will be deep research, and another one will be coding, right? So I think that two types of the AI agents have been widely used across the entire communities.
Yeah, thank you for answering.
Thank you.
Yeah, I think we are over time. So thank you so much for sharing your research with us, and hope that we'll stay in touch. And if other people have questions, feel free to reach out to Chao. Thank you so
Okay,
much.
Yeah, no problem. Thank you. Bye bye. Thank you.
Bye bye.
Bye.
Thank you. Keep in touch.